Hello guys, welcome to my channel. So today we are going to work on a completely new series which is going to be of a Java developer interview, which is going to be for a 3 to 7 years experienced Java developer. So this series I'm creating so that if you are looking out for interviews and if you don't know where to start, you can start with this video series. So here in this video I'm going to cover the questions that I basically ask in the interviews for the Java developer position. So these questions are a bit advanced, so if you know about Java, basics of Java, then this video series is for you. So as this is a series, so I'm going to upload multiple videos of this series. So the first video is going to be on the topic multi-threading and concurrency, and similarly we will proceed ahead. So before we move on to that part, if you're new to my channel, if you haven't yet subscribed to my channel yet, please do. I see that a lot of you guys are doing the awesome job of watching my videos, but not the awesome job of subscribing to my channel. So please do that. It's a very humble request. So let's not waste any more time and let's start this video series. Okay, so multi-threading and concurrency. So this is a very big topic and very advanced topic as well. And a lot of people are not aware about the basic concept within multi-threading and concurrency. So we are not going to talk about what is a thread, what is a daemon thread, stuff like that. We are going to dig deep into it so that you get enough confidence while attending interviews. So the first question is, what are the differences between thread, runnable and callable? When should you use each? So if I talk about the basic difference, it is in the basic definition. So thread is a class, okay, runnable is an interface, and callable is also an interface. Now thread, runnable, callable, this is the basic difference. Now if we dig deep into it, so as I said, thread is a class but the other two are interfaces. So in runnable, an interface that should be implemented by any class whose instances are intended to be executed by a thread. Alright, that is your runnable. Now an interface similar to runnable, but it allows thread to return a result and throw checked exception, that is callable. So callable is runnable plus it allows you to return a thread, return a result and throw exception, checked exception. Alright, so this is the basic difference. Now if we look at the example, so let's first talk about thread. So here you can see that we have my thread, and this is the class which is extending thread functionality. Now you have to override run method, but we don't call run method directly, we call it through start method. As you can see, we have called the start method and through that we are running the thread functionality. Now how it works, you can create a new thread by extending the thread class, override its run method, then start the thread using the start method. Okay, that is the basic functionality. Now this is not recommended if your class needs to extend another class, because Java doesn't allow you to extend more than one class, which is it is only allowing you single inheritance, and that is through class. Okay, now coupling between the task and the thread is high. That is how this is not actually flexible for reusability, also tightly coupled. Now this returns nothing, which is the functionality with callable. Now runnable is also not fixing a lot of things with thread, but what it gives you is, as you can see here, there is not much of a difference. Instead of thread, you are implementing runnable, that's it. All the other functionality looks exactly same to the code which we have seen before. Now what is better here is that it is providing you better flexibility, as you can use composition instead of inheritance. Now your class basically can still extend a class or implement another interface, right? So it is not restricting. Now again, this is not returning you a value, and that is why we have callable, right? So if we look at the example of callable, This is a bit different. If you can see here that here we have a class implementing callable, but you specify that okay, you are going to return string type of data, right? That is why in the call method the return type is string. Now when you actually create the instance of this class myCallable, how do you do that? You don't need executor service as such, but if you use executor service, then this is going to provide you better functionality for multi-threading with result. So that is why in this example we have first created the executor service instance, and then we are submitting that instance with our callable object. Now here if you see, the main role is future. So this future basically gets the output out of it, and when you get the output you can print it, and also through this future you can throw exception. So how it is working, it is implementing the callable interface, then define the call method, use an executor service to execute the task, retrieve result via future object. Alright, now if we talk about when should you use each, so this is very easy. If you don't need to return any output, then use thread, it's okay. If you have a major functionality that your class should be using another functionalities like another class or maybe more features, in that case you should not use thread. In that case you should use Runnable. But callable is pretty defined that if you have to return a result, if you have to throw exceptions, in any case use callable. This is very much straightforward, right? Now synchronized block versus reentrant lock. So synchronized block is a very basic and known feature to everyone. So this is a built-in feature which Java provided to control access to block of code or methods by a single thread at a time. Now reentrant lock is a class in your concurrent package. Remember that this is in a concurrent package, and this provides more control and flexibility when we compare it to synchronized block. Now how it does that? So in synchronized block it cannot try for a lock without waiting, so there is no polling or timeout. So here we don't get that flexibility. Also it only provides you exclusive locking, so there is no fairness or lock interruption here. Now the good thing is that it is simple to use and less error prone. So if you want a more straightforward basic locking mechanism, then use synchronized block. Now it automatically locks the it automatically releases the lock when the thread exit the synchronized block or method, even in the case of an exception. So for most general purpose thread safety task where the advanced feature of reentrant lock is not required, then use synchronized block, right? So this is the basic example as you can see here. Now talking about reentrant lock, this provides you explicit locking and unlocking. So you can call lock method and unlock method to do locking and unlocking, right? Now it also gives you timeout functionality, interruptibility. So you can use try lock method basically which is going to specify a time to wait for the lock. Now interruptibility method allows the thread to respond to interrupts while waiting for the lock. Now for fairness, you can acquire locks giving preference to threads waiting the longest, right? So this is actually giving you more control over the thread synchronization. That is why it is better suited for scenarios which involves complex thread interaction, and this is not going to be in many basic scenarios. So a lot of times you will use synchronized block, but in case you have a more complex threaded environment, in that case you should use reentrant lock. Now how does the CountdownLatch differ from cyclic barrier? Now this is not a basic question, this is how we are going deep. So CountdownLatch is a thing that allows one or more thread to wait until a set of operations performed by the other thread is complete, right? Now cyclic barrier on the other hand is allowing a set of threads to wait for each other to reach a common barrier point. Okay, so remember that. So here we are talking about barrier action, and in the countdown latch scenario we are talking about waiting for an operation to be completed. Alright, now how are these two linked with each other? Like, why are we still talking about the difference when they are actually not doing the same thing? So how these two are related? So let's talk about the use case first. So when you need a thread to wait for multiple threads to complete before proceeding. So if you want to have an order, let's say if you want thread 1 to be completed first and then thread 2, you can use countdown latch. Okay, so in that case your thread 2 is going to wait for the thread 1 to complete its task, and then thread 2 will continue, right? So let's say if you have to start a computation only after multiple services are initialized, or waiting for multiple threads to complete task before aggregating result. Let's say if you want to multiply 1 times 2 and the result with times 3. So in this case you need to first let the first thread complete the transaction of 1 times 2, and then in the second thread you will multiply the result with 3, right? So here you can have an order. Now for cyclic barrier, this is when multiple threads need to coordinate and proceed together at a specific point. Now if you see here, the basic use case is coordination. Here we are talking about a particular order or a correlation, like how they are going to coordinate with each other. So in that case we have two options, either we can use countdown latch or cyclic barrier. But for cyclic barrier cyclic barrier divides a task into phases and then ensures all threads complete a phase before moving to the next. So here we are synchronizing multiple threads performing parallel computation, right? So I hope this part is clear, that the basic use case here in the cyclic barrier is different than the countdown latch. Now if you take a look at the code of the countdown latch, here what we are saying is create 3 worker threads, okay, and then iterate over it. So now first thing is that you want to use 3 worker thread. Now you have created 3 threads and you are printing here that this thread has completed its task, and then you will decrement the count using this countdown. Now what this is doing is, a countdown latch cannot be reused after the count reaches 0. So that is why we are decrementing it using countdown method. Now thread calls the await method to wait for the count to reach 0, right? So what it is waiting for is the complete execution. So once that is completed, you are going to print all tasks completed, proceeding further. Alright, so this is useful for scenarios where one thread must wait for multiple other threads to complete their task. Now talking about cyclic barrier code, here if you take a look, what we are doing is, so again thread is calling the await method to indicate they have reached the barrier. Now when the specified number of threads has called await, the barrier is released and all threads proceed. So here the barrier is 3. Now if we talk about reusability, this barrier can be reused for subsequent synchronization, whereas in your countdown latch it cannot. Now here the barrier action is optional and it can be executed by one thread when all the threads reach the barrier. Okay, so here if you can see that first we have created the cyclic barrier. So here this object is created with a count of 3. Alright, so when 3 threads reach the barrier, by calling the await method, the barrier releases them all simultaneously. Alright, now how we are starting the thread, we have this loop. So a loop creates and starts 3 threads. This is similar to what we have done in countdown latch. Now inside each thread calls barrier.await to signal that it has reached the barrier. Now the thread then blocks until all 3 threads have called await. Once all the threads reach the barrier action runs. So the action is your system.out.println. So after the action, all threads proceed beyond the barrier. Now talking about reusability, so unlike CountdownLatch, cyclic barrier can be reused. If the threads call await again, the process repeats. So that is the basic difference. Now this question, what are the differences between parallel stream and sequential stream in Java 8? How do they handle performance in multi-core system? So this is specifically for Java 8 stream feature, but I have put this up in multi-threading and concurrency because here we are actually going to use parallel stream in a multi-threaded environment, or if we want to use multiple thread. Now the basic difference is that a sequential stream is going to process each element one by one in a single threaded manner. Okay, that is the basic thing about sequential stream. Now parallel stream, as the name suggests, this is going to divide the data into multiple parts, alright, and then process each part parallelly using multiple threads. So that is the basic difference between these two. Now how does these work? If this is a question. Now this uses single thread to process all environment, so this is not for multi-threading, and this is suitable for smaller data set or when the overhead of parallel processing outweigh its benefit. That is a very big con of parallel stream. Okay, now if you take a look at this code, here we have a very small data set, so we have only 5 elements. So we have created a stream, numbers.stream. Now here we are just trying to create a sum of these 5 elements. So we have map to int, integer value, and then we are using sum method, and then we are printing it. So this is a very basic operation. Now talking about parallel stream, so the elements of the stream are processed in parallel across multiple threads. So this uses ForkJoinPool internally to process elements in parallel. So parallel stream can basically speed up processing for CPU bound operation with larger data set, but again, like I said before, they have the overhead due to thread management and synchronization. So use case wise, they are most effective when operations are independent, computationally expensive, and the data set is large. So a lot of scenarios where you will see parallel stream being used is going to be very minimal. So there are a very few use cases where you see parallel stream working as efficient as you expected, right? But you have to know about it. So if we talk about the same code like before, so here there is not going to be much performance difference because the purpose is being defeated if we are talking about parallel stream. So it is a very small data set, and again we are doing the same thing, but internally it is going to split the list into parts and process those parts in different thread. Okay, now talking about the second question, how do they handle performance in multi-core system? So a sequential stream does not take advantage at all of multiple cores. So this is not specifically made for using multi-core system. So how many cores you have in your system, it doesn't matter because it is going to use the single thread. That's it. Now talking about parallel stream, here it matters how many cores to have in your system because it is going to utilize each and every core to maintain multiple threads basically. So here each thread runs on a different core, allowing the workload to be divided and conquered in parallel. So if you have 8 core CPU, in that case you have 8 thread to work on a single task. Now I talked about ForkJoin framework. So here we are using that framework to manage the parallel execution. So data is divided into tasks that are processed concurrently, and then the result are merged. So by default, the ForkJoinPool uses as many threads as there are available processors. Like I said before, if you have a 8 core machine, 8 threads might be used to process the data. Now what is the performance impact? So parallel stream scale with the number of available cores, meaning performance improves with larger data set on system with more cores. So let's say if you are working on a large data set on an 8 core system versus on a 16 core system. So 16 core system will generate more performance when we compare with 8 core system. And that is a very basic thing. Like you do video editing on a higher performance laptop versus a simple average performed laptop, so you will see that the video editing is much efficient in your high-end laptop, right? So that is very well known. But again, overhead consideration. So there is an overhead in dividing the task, managing thread, and merging results. So 3 things, right? So that is how it is going to impact your performance. Now we have talked about fork join, so let's talk about another question. What is a fork join pool? How does it differ from executor service? Now fork join pool is actually your executor service, which is designed for tasks that can be divided into smaller subtasks, right? So this is introduced in Java 7. So this is the basic difference, right? It is actually executor service, but designed for tasks that can be divided into smaller subtasks. Now task splitting is basically your divide and conquer. So fork join pool is optimized for divide and conquer tasks, where large tasks are recursively split into smaller subtasks, and that is why we also use it in parallel streams. Now it uses fork join task class, which allows tasks to recursively fork new subtasks and join their result. So yeah, that is that. Now here we have efficient thread management. Now the pool contains a set of worker thread, but it can dynamically adjust the number of threads based on the task being executed. Now talking about executor service, so basically in most of the cases you are going to use executor service. If you don't want to bother about CPU bound operation, right, use executor service, because it is a very general purpose interface for managing a pool of threads to execute tasks concurrently. But if you want to use CPU bound or IO bound task, then use fork join pool. Now here the task execution, it, like I said, it manages a pool of threads that can execute tasks submitted by the user, and it supports a wide variety of task submission methods such as submit, invoke all, and provides method for shutting down the service gracefully. Now unlike fork join pool, which is optimized for recursive parallel processing, executor service is a more general purpose thread pool, right? That is the basic difference. Now fork join pool performance wise, fork join pool is going to generate high performance for parallel recursion, but might have overhead for simple tasks. On the other hand, executor service is more flexible and efficient for diverse tasks, but lacks work stealing. Now what is work stealing? So work stealing is a technique used in parallel computing to improve the efficiency of task scheduling across multiple threads, right? I won't go deep into it, but yeah. So what was the difference? So difference was that fork join pool uses work stealing to balance the load across thread. On the other hand, executor service has no work stealing, right? Now fork join pool is designed for parallel recursive divide and conquer tasks. On the other hand, executor service is a general purpose thread pool for concurrent task execution. So yeah, this is the very basic difference. Now we have talked about 2 words since we started multi-threading and concurrency. We have talked about parallel execution and we have talked about concurrency. So now what is the difference between parallelism and concurrency? So let's talk about that. So parallelism and concurrency are both basically identical if you talk about in a sense. So concurrency is to manage multiple tasks at the same time, and parallelism refers to the simultaneous execution, right? So terminology wise they sound very similar. So let's talk about the definition. So concurrency manages multiple tasks at the same time, but parallelism executing multiple tasks at the exact same time. Alright, so in concurrency you are managing multiple tasks, but in parallelism you are executing multiple tasks. So in concurrency the tasks are interleaved, they may not be executed simultaneously, but in terms of parallelism tasks are always executed simultaneously. Now talking about a basic use case, so let's say that a program that allows a user to type while downloading data in the background, that is concurrency. But when a program where large data is processed in parallel by splitting tasks across multiple core is parallelism. Alright, so concurrency uses a single core to manage many tasks. On the other hand, parallelism uses multiple cores. So yeah, that is the very basic difference. Now the next question, what is the difference between volatile and synchronized? When should you use one over the other? So they both are the keywords and used in multi-threaded environment. That is why this is a big question. So the purpose of volatile ensures visibility of changes to variables across thread. So if you have read write operation on a variable and you want to ensure that they are reading exact same value, then use volatile. On the other hand, synchronized ensures mutual exclusion, which means that only one thread execute a block of code at a time. Now the use case of volatile is very simple, that use it on a variable or let's say a flag variable that need visibility across thread. But synchronized is vast, which means that if you have complex thread safe operations on shared resources, then use synchronized. So synchronized can be used on multiple places, but synchronized can be slower due to locking and thread contention, especially in highly concurrent environment. But volatile is minimal. Volatile provides you minimal overhead, but only works for single variable access. So yeah, so visibility wise, they both ensures visibility, so that is there. Talking about locking, volatile doesn't lock, but synchronized involves locking and unlocking. That is why there is an overhead. Now talking about atomicity, volatile does not guarantee atomicity for complex operation, that is incrementing a counter. But synchronized guarantees atomicity for code inside a synchronized block or a method. Now let's take a look at where to use which. So let's say if you have a single variable that needs to be updated and accessed by multiple thread, then use volatile. Now when you want to ensure that we have mutual exclusion and we need to prevent race condition, then use synchronization. So in this case, let's say if you want to increment a shared counter variable, then use synchronized keyword. Now the next question, what is the difference between a livelock and a deadlock? So these are some of the scenario based question which can be asked, like what is the race condition, what is a deadlock, and livelock. So basic difference is in the definition. So deadlock is when threads are blocked indefinitely waiting for each other. But in the case of livelock, the threads are active but not making progress, right? Now talking about progress, in deadlock no thread can proceed because each one is waiting for the other. But in livelock, threads continuously attempt to progress but fail to make any real progress. Now how we are going to solve each scenario? So for deadlock, it requires breaking the circular wait, possibly through timeout, preemption, or resource ordering. But in livelock, it requires changing the strategy basically, or introducing randomness to break the cycle of continuous execution. So now anyone can ask in which scenario each situation will occur. So let's say that if two threads wait for each other's resources, let's say a thread 1 is waiting for thread 2 resource and thread 2 is waiting for thread 1 resource. So this is a circular dependency and this is a deadlock scenario. Now let's say that two threads are continuously trying to avoid each other actions but nothing is achieved. So that is livelock. Now let's say that we have two services, one is service A, one is service B. Now both of these are attempting to acquire a lock on a shared resource, let's say a file. Now both services are programmed to avoid deadlock by ensuring they never hold the lock when waiting for the other service. Now to prevent blocking, let's say if service A finds the lock held by the service B, it immediately releases its own lock and retires, and vice versa. So this intention is to avoid deadlock. Now let's say if both services are continuously locking and releasing resources in this manner, so neither service is making progress because each is waiting for the other to release the lock before proceeding. But they are actually retrying, but they are stuck in a cycle, constantly giving up the lock and attempting to require it again. So this is your livelock. Alright. Now let's move on to the next question. What is the purpose of concurrent hash map? How does it differ from hash map or a collections.synchronized map? So this is one of my favorite question. The reason why I ask is because it is a very basic and deep question. So everyone knows that when you have to use a hash map in a multi-threaded environment, use concurrent hash map. But why? Because hash map is not synchronized. That is why. Now we have one method, collections.synchronized map, which makes our normal hash map synchronized hash map, right? So when we have this functionality, why do we need to use concurrent hash map, right? So the basic difference is that now in concurrent hash map, we don't lock the entire map. We lock segments. We have basic 16 segments and we lock each segment. Now if let's say you are working on a segment but the other thread is going to work on the other segment, in that case there is no lock, do it. So that is how it provides you better performance when you talk about concurrent hash map. Now most read operations are lock free, which allows multiple thread to read concurrently without blocking. So this is another good functionality. Alright, now let's move on to the next question. How does ThreadLocal class work? Provide a practical example where it is useful. So we talked about synchronized and volatile. So this is going to be similar to this. Now ThreadLocal in Java is providing you ThreadLocal variables. Each thread accessing a ThreadLocal variable has its own independent copy of the variable. So this means that changes made by one thread to ThreadLocal variable are not visible to other threads, right? Now this is a very common way to store data that is specific to a particular thread, like let's say sessions or DB connections, right? Now how does it work? So when you create a ThreadLocal object, it provides a method get to retrieve the current thread value, and we also have set to set the value for the current thread. Now each thread gets its own copy of the variable and it can access or let's say modify its value independent of other threads. Alright, so now if you take a look at this example, we have a thread local value and we have initialized it, right? Now talking about the threads, we have two threads here. We have thread 1, thread 2, and thread 1 is setting the value of thread to 10 and then fetching the value. Meanwhile thread 2 is setting the value to 20 and getting the value. Now we have started the thread like thread 1.start and thread 2.start, and then we have joins as well, so which means that first thread 1 will complete and then thread 2 will complete. Now the output here is going to be thread 1 is going to return 10 and thread 2 is going to return 20. But when we use main thread, which is at the bottom, this is going to fetch you the very basic initialized value, which was 0. Alright, now where you can use it. So this is useful for storing data that is unique to a thread, such as I have already told you, the basic use case is DB connections and user session data. So you can use ThreadLocal in that case. So this was all about multi-threading and concurrency. So this was it for this video. In the next video of this series, I'm going to talk about memory management. So stay tuned for that, and thank you so much for watching this one. Don't forget to like, share and subscribe. Thank you so much. Have a good day. Bye bye.